For experimental 1, the students are preparing the aqueous copper amine solution, or known as the stock solution, which should be around 0.2 concentration. And through this, we weigh the accurate amount of copper amine and then add distilled water to help dissolving the reactants. The students then use circular motions to help dissolve the reaction. Also, placing the flask in the handle in circular motions will help increase the temperature, which then increases the reaction. This is a diagram of how the dilutions will occur. By adding a small volume of the stock solution to your dilution 1 and calculating the concentration, and using that concentration to calculate your volume that should be added for dilution 2, and then so on. When adding the volume of the distilled water, you should make sure when adding it into the flask that the meniscus should form and to not overflow the meniscus point. If so, you should start the solution over. However, if the solution becomes too cloudy, head over to the hood station and add a few drops of ammonia to help get rid of the precipitate that formed in the solution. Now each student will perform a series of dilutions from the stock solution to create dilution 1, and they'll take that small volume from the stock solution to make the dilution 1, and take the small volume from dilution 1 and make the second dilution, and then a small volume from the second dilution to make the third dilution. And they'll use a pipette to transfer into the volumetric flask and adding water into the meniscus mark. And also, if any cloudiness appears, they'll add 10 drops of the ammonia. Also, the student ensures they prime the pipette before usage in transferring the solutions. Also, through the dilution equation, which is M1V1 equals M2V2, we're able to calculate not only the concentrations for each of the dilutions after we finish, but also we are able to add the volume we add for each dilution. Blank solution should also be made in addition to the other dilutions, which includes water and a few drops of ammonia. After each solution was made, we then did our spectrometer analysis, and through our spectrometer analysis, we went and put each solution first with our blank solution, which was zeroed first, and had our setup from the range of either 560 to 600 nanometers at the max to help cover all wavelengths. And through this analysis, we found that as the concentrations increased, the absorbance also increased. And this spectrometer analysis helped allow us to see this linear pattern between the absorbance and our concentration, which helps supports also the copper amine has a linear relationship with this.
Go home, folks.